So today's assignment is binary. And the first thing I want to tell you about binary is it's a way of counting with ones and zeros. So, for example, it looks like this right here, this number here. And why do we count in ones and zeros? Let me show you. First off, humans count in the. Wait, that's a bucket. Humans count in a decimal system, meaning we have 10 numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. That is 10 different numbers, okay? And that's why we call this the deci, that means 10 mole system, okay? In the binary, bi means 2. The binary the binary system, you have two numbers, 0 and 1. That's it. There's other numbers. There's other counting number systems too. For example, there is octal, which only has 8, so 0 through 7. There's hexadecimal. There's 16, and so on and so forth. So we have always, your whole life, you've always counted like this. So there's 0, 1, 2, 3, 2, 3, 4, 5, 6, 7, 8, 9, and guess what the next number is? It is 0. Then you just changed the one in front was a 0, wasn't it? The whole time? So the next number after 9 is 0 again. We start over from the beginning, and then we bump this one by 1. Then the 0 turns to a 1, a 2, a 3, a 4, a 5. Of course, these are 1s the whole time. And then this is a 6, a 7, an 8, a 9. Sorry about the curling here. These are 1s the whole time. And then after this 9, this turns to a 0 again. And then this number bumps up, and so on and so forth. Keep bumping this up until it maxes out, and then you bump up the next one after it. That's exactly how. Let me change. That's exactly how binary works. Binary works the same way. Just to let you know, it's the same way of counting. But first off, you're probably wondering why we use that system. Why do we use this system that we just did? And the reason being is humans have 5 fingers on this hand and 5 fingers on the other hand. This person has 2 right hands, by the way. So we have 10 fingers. So it's easy to count. That's why. So we've always counted by the decimal system. But binary is the best way to do it in a digital electronics world where everything is either 1 or 0. And it's pretty much counting the same way. 0. Then what's the next number? 1. Then what's the next number? Well, 0. But then you have to bump this one up by 1. Then the next number is 1. So we keep this 1 here, right? And then what's the next number after this? Oh, it's maxed out. So we have to reset this to 0. Which means this resets to 0, which means this goes to 1. It just increases much faster is all. And then this goes to 1. And then once this one maxes out, which it has, it goes to 0. And then this one bumps up. So this is staying the same for a while. And then this one bumps up to 1. Now they're all maxed out. Then you go to here. So it just looks like this over and over again. So it's very similar to the other system. But just you only have 2 numbers. That's it. But counting works the same. So that being said, going to our assignment, the very first step you're supposed to do is to convert regular numbers, which we call decimal numbers. You see the little, what is that called? The 10 right here in parentheses. That means that this number 19 is a decimal system. Okay, so pretty much the regular way you're used to counting, and you have to convert it to a base 2 system, which is binary. So a base 10 to a base 2. So decimal to binary. So how do we do that? And the trick is just to do, you pretty much divide by 2 over and over again and then write the remainders down. So it sounds a little funky. It's actually much easier than it looks. Okay? So let's see here. So for the example problem, they did 19. Oops. They did 19. And then we want to convert the base 10 of 19 to a a binary system. So base 2. So to do that, you take 19 and you divide it by 2. How many times does 2 fit into 19? And the answer is Let's see. 10 times? No, because that would be 20. Yes, it only fits 9 times. Good. So it only fits 9 times. Um, is there a remainder left? Yes, there is, because 2 times 9 is 18, and so there is a remainder, right? So there is a remainder of 1. Now take that 9, your answer here, and then divide that by 2 and go, how many times does that fit in there? And I think you guys agree 4 times. And there is a remainder, because 2 times 4 is 8. There would be a remainder of 1 there. Now take the 4 and divide. How many times does 2 fit in there? 2 times. And is there a remainder? No. No remainder. And then we take this answer, right? We keep moving down and we take the 2 and go, how many times does it fit in there? 1. Is there a remainder? No. And then we take this answer, and then when you can't do it anymore, we're done, we can't fit this in there, then we just say the remainder is 1. Okay? Because I'm finished now. I can't divide anymore, and I just take the remainder and stick it here. And now the number is backwards. We write it this way. This is the most significant digit. So we go 1, then 0, 0, 1, 1. And I think that's it, right? Yeah, I just want to make sure. So 1, 0, 0, 1, 1. Let's look at our sample. And the answer is 1, 0, 0, 1, 1. And they got the same answer as I did. So once you cannot divide anymore, you're done dividing. Then you just write these remainders, whether there was a remainder or there wasn't, and then you just put them in order. And this just pretty much says whether there was a remainder or not. So if I do, so your work is to do these in your notebook or whatever, and then you send me the answers here. I'll do let's do 58 here. I'll do a larger one for you guys. And 58, and we divide it by 2, and it fits in there. Let's see, 25 times would be 50 plus 4 more, so 29 times, and there would be no remainder here because it's an even number. So that's it. So let's just write this one down right here. Right now 2 fits into there. Let's see here. 22 times would be 11, but there's 7 more, so that's 3. So that you can just kind of second guess yourself and go, let's see, 13, that would be 26. Nope. 14 times, that would be 14 times 2 would be 28. Yep. So there is a remainder though, because 14 times 2 is 28, and that's the only, it can fit in there 14 times, that's it. But there will be one left remainder. Now let's write that 14 and divide into there. And we all know that 2 fits in the 14 7 times with no remainder at all. Fits in there perfectly even. Then let's take that 7. And how many times does 2 fit into the 7? It fits in there 3 times, but there will be one left over. And now let's take that 3. And how many times does 2 fit in there? It fits in there once, and there's 1 left over. And now let's take that 1. And how many times does 2 fit into that? It doesn't. So there's that 1 remainder, and we're done. So the answer is 111010. So 111010. That is the binary number that equals 58. But this is the binary number. I saw, oh, here we go. Actually, so that's it for there. Let's go back here. So you're just doing these, and it's pretty much the same thing. It's just sometimes it's a little longer than others.
There's not a shortcut to that?
No, no, this is the longhand way. The shortcut way would be this. Sorry. You could just search, what is it, the decimal to binary. Just search decimal to binary, and here's a converter. And then you just type in 58 and convert, and this is it's 111010. 111010, and is that what I got? 111010. Yeah, so if you want to check your work like that, that's fine. But I just want to see that you did the work, you know? So that you kind of know how to do it. So going back to this, sorry, where's your assignment here? I think I clicked off of it. So going back here to this work, the next part is to pretty much do this again right here, but do it for the number 0, do it for the number 1, do it for number 2, do it for number 3, number 4, number 5, number 6, and number 7. So they did already 5 for you. They already did number 0 for you. 0 is 0, 0, 0. So just write you shouldn't have more than 3 numbers here. So even if you only get 1 number or 2 numbers, fill the rest with zeros. So if you're like, oh, the answer here is 1, okay, but put 2 zeros here. If the answer here is 1, 0, then put 0, 1, 0. So fill this chart out. Then working, and that's pretty much it. All you have to do is convert these binary numbers. Oh no, sorry. The next part was converting binary to decimal. So going back the opposite direction. Quite interesting how to do that. So let's see here. New. Do you want to save? No. All right. So it's quite interesting. So let's do 58. What was it? It was 11101, right? I think that was the number. Let me just double check that real quick that I was correct. That 58. Oh, we did it in the calculator. 111010. 111010. So I forgot a 0 there. Okay. So if I want to change this to regular numbers like decimal, so this is a base 2 number, because I have to write this because somebody might say, oh, this is 111,010. You know, if you thought this was regular numbers, technically that could be a regular number, you know. So we have to put base 2, that's a base 2 number. If I want to convert this over, here's how you do it. Each one of these is worth something. What does that mean? I'm going to give you this much money. Everybody look at this. Say I send everybody this much money. How many ones do I give you? None. How many tens do I give you? I give you 1, right? So no ones. No, I give you 1 10. And how many hundreds do I give you? I give you 3. So these are the hundreds place, these are the tens place, and these are the ones place. So if I give you this, 5,849, I would give you, this is the least significant bit or digit, and this is the most significant bit. And what does that mean? This is the most significant one, right? Which one means the most to you? Well, this one, because this means I'm getting $5,000. This one just means I'm getting $9. This one means I'm getting $10. This one means I'm getting $800. So if I give you 5,000 and I give you 800 plus, and I give you $40 plus, and I give you $9, these are worth 1 each. If you add those all up, you get this number. It's pretty simple, really. Same thing here, except 111010. Except these are worth 2. Let me erase this up here, by the way. I need a little room here. So these are worth 2 to the 0 power. This digit is worth 2 to the first power. This digit is worth 2 to the second power. This digit is 2 to the third, and we just do this all day. 2 to the fourth, and this one's worth 2 to the fifth power, and so on and so forth. And what does that mean? That means that this bit right here is worth 1, because 2 to the 0 power is 1. 2 to the first power is just 2. And we just keep doubling. 2 to the 2 is 4. And then we double that. That's 8. What's double 8? That's 16. What's double 16? That's 32. The next one would be 64. The next one, 128, so on and so forth. So now, if you want to know how much this is worth, right here, how much is this worth? You go, well, let's see. I don't have any ones. Do I have any twos? Yes. Plus, do I have any fours? No, I do not. Do I have any eights? Yes. In fact, I have an 8. I have a 16. And there's a 1 here, so I have a 32. So 32 plus 16 plus 8. And I don't have any 4s. I have a 2, and I have no 1s. So this is the math right here. 8 plus 2 is 10. Plus this is what? 20 that's 26, right? 26 plus the 32? That's 58. So I was right. This number right here is 58 in binary. So all I'm doing is just adding these up. 2 plus 8. I was trying to do the math here. 2 plus 8 plus 16 plus 32. That's 58. And all you're doing is seeing if these values are on or not. You know, is there a value to this? Yes, then add it. If there's not, then don't add it. And that's all there is to it. Now, interesting. I saw a shirt one time, and it was obviously for nerds, and it said, um, "There are people in the world," and it said, "Those that understand binary and those that don't." I don't want to write it all out. It said, "There are this many people in the world, those that understand binary and those that don't." And if you try to convert 1 0 in binary, remember, this is worth 2 to the 0 power, this is worth 2 to the first power, and so on and so forth. So this is worth 2, this is worth 1. So there are no 1s, so there's just a 2. So this is the answer. This means 2 in binary. So if you see a shirt, somebody wearing it, says there are, and I have the shirt, and I wear it, and somebody's like, "What does that mean? There's 10 people in the world, those that understand binary and those that don't." And I said, "Well, you're one of the ones that don't. That's all that means, man." And then they're like, "Okay." Anyway, so so hopefully you guys get binary now, and you can do this all day long. So example, if I give you a random number, 10001, if I said, "What is that number in decimal system?" Your regular way of counting, you would just go, let's see, this is worth 1, this is worth 2, these are worth 4, just keep doubling. This is worth 8, so if you look, these are worth 8, these are worth 1, and then double this again, these are worth 16, that's a 16, and then go, okay, it's a 1 and a 16, 17, that's it. Yep. This is 17 in binary because there's only a 1 and a 16, that's it. So you want to see less ones because it's easier to count. You know what I mean? So if I said, "What is this?" If I said, "What is that number?" This is easy to. You're going to go, "Oh, this will be easy to count because there's not that many ones. I don't need to add so much." This is. Oh wow, that's a big. I must have changed my brush size here. So this is worth ones. This is worth twos. Just keep doubling. 4, double, double again, double again. Oops, that's 32. Sorry. And this is 64. So 8, 16, 32, 64. And so really it's just 2 plus 64. Yep, 66. That's it. So this number right here in binary is 66. That's all there is to it. And that's why, did you guys ever notice that when you buy a hard drive or anything, it always comes in a 2 gigabyte or a 4 gigabyte, or you buy the 64 gigabyte iPhone or the 128, just double that again, or it's the 8 gig or the 32 gig. Everything is by binary. Did you guys notice that? Or converted from a binary number? Like it's just double, 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 double. So that's because 64 doubled 64 is 128, and double 128 is 256, and double 256 is 512, and double 512 is 1024, and so on and so forth. So mostly electronics come in these sizes for gigabytes and stuff, just to follow along with that. And that's pretty much all there is to it, folks.